Stage 2 LOX load is complete.
And there's that call out. And this will wrap up propellant loading for
Dragon
both stages
in
of
auto
the Falcon 9. Dragon is also performing its final health checks to make sure all the vehicle's primary systems are ready for its rendezvous with the International Space Station. And you may have noticed some white clouds around the vehicle, but that's actually quite normal. Those clouds you see are the chilled gas above the LOX tank liquid surface that we vent overboard to maintain pressure in the tank as needed. And when that gas comes out into contact with the warm, humid Florida air, the air condenses into clouds and water.
Now in just about 5 seconds, Dragon transitions to internal power. Falcon 9 computers will enter startup mode, which is when the Falcon 9 flight computers... There you go.
Dragon is in countdown.
Is when the Falcon 9 flight computers take control of the countdown and will guide the rocket through the last seconds before liftoff.
Go for launch.
All right, both stages are now pressurizing for launch. At launch, the International Space Station will be over the Indian Ocean, south of India, at an altitude of 261 statute miles.
T-minus 30 seconds.
Counting down for NASA and SpaceX's 27th commercial resupply mission.
$15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engines full power. And liftoff of CRS-27. Go Falcon, go Dragon.
Falcon 9 soars off the launch pad. Dragon now on its way to the International Space Station with important new science experiments and crew supplies.
Stage 1 chamber pressure is nominal.
Falcon 9 has successfully lifted off from historic launch complex 39A in Florida. We're now coming up on our max Q in about 20 seconds or so, which is the point of maximum aerodynamic pressure the vehicle will go through during its flight.
Sonic. Max Q.
And there's that call out for max Q. Coming up next are 5 events back-to-back. First is main engine cutoff, or MECO, which is when all 9 of the Merlin 1D engines on the first stage will shut down. After those 9 engines shut down, the first and second stages will separate, also called out over the nets as stage separation. Then the first stage will flip around to make its way back to its landing site, the drone ship named a shortfall of gravitas. The second stage will then ignite its Merlin vacuum engine to boost Dragon to low Earth orbit during SES-1. And the last event is the boost back burn to reduce velocity of the first stage in preparation for atmospheric entry. And this whole sequence will take place over about 30 seconds or so. Now we should be hearing that call out for main engine cutoff in about 20 seconds from now. Wonderful tracking shot of our rocket.
MECO. Stage separation confirmed. In-back ignition.
Stage 1 boost back startup.
And there's all of those callouts for those milestones. So we had MECO, stage separation, a stage 1 flip, second engine start 1, and the start of the partial boost back burn. While a boost back burn is normally performed in order to return the first stage to one of our landing zones, here we are just performing a partial boost back. This shortened burn, possible due to payload weight, will allow us to recover the Falcon 9 booster much closer to the coast and shorten the drone ship's journey back to shore by about 1.5 to 2 days.
Stage 1, boost back, shutdown.
And there's confirmation of boost back shutdown. If you're just tuning in, you're watching a live webcast for the 27th commercial resupply mission to the International Space Station for NASA. This is SpaceX's 17th mission for 2023 and the second Dragon flight to the International Space Station this year. We lifted off from Kennedy Space Center's historic Launch Complex 39A just about 3 minutes and 45 seconds ago. On the left side of your screen is the Falcon 9 first stage that is making its way back to Earth, and on the right side is the second stage. The second stage, and you can see that MVAC engine there. As a reminder, today's mission marks the 7th flight for this Falcon 9 booster, which previously supported the Amazonas Nexus mission, SES-22, iSpace's Hakuto R Mission 1, and 3 Starlink missions. Now, in order to make its way back to our drone ship, a shortfall of gravitas, it has 2 more burns to execute. The first is the entry burn, where 3 of the Merlin engines, engines 1, 5, and 9, will reignite. This helps to slow the stage down as it re-enters the upper part of the Earth's atmosphere. The second burn is the landing burn, and this is a single engine burn, engine 9, that brings the vehicle's speed down rapidly in order to land on the drone ship. Now, occasionally on your screen, when the booster is visible, you may see some nitrogen gas bursts, and these are used for attitude control as the booster makes its way back to the drone ship. Falcon 9 is also equipped with 4 hypersonic grid fins positioned near the top of the first stage. And once in the atmosphere, Stage 1 is only using the grid fins for steering as it makes its return to Earth. These titanium grid fins will orient the rocket during re-entry and guide the rocket during descent. And there's that call out for nominal trajectories. On the left side of your screen, you can just make out some civilization of Earth. On Earth. In just about 8 seconds from now, we should see that first stage entry burn begin.
Stage 1 FTS is saved.
Right now, on the right side of your screen, you can currently see that. You can currently see Stage 2, and there's confirmation of first stage entry burn startup, and probably saw it as well. Again, this is the first of 2 burns that the booster performs before landing on the drone ship.
Stage 1, entry burn, shutdown.
Now, as we get closer to the first stage landing, it's good to note that the Falcon 9 first stage is equipped with 4 landing legs made of state-of-the-art carbon fiber with aluminum honeycomb. And these are placed symmetrically around the base of the rocket and deployed just prior to landing. If successful, this landing will mark the 178th time that we've recovered a first stage booster, including both Falcon 9 and Falcon Heavy missions. And we're about 15 seconds or so away from landing. And the vehicle is traveling about 1,600 kilometers per hour. And this really puts into perspective the deceleration of the rocket. In the span of less than a minute, we'll have reduced from twice the speed of a jet all the way down to 0 as the rocket lands.
Stage 1, landing burn.
There's the start of that first stage landing burn on the left side of your screen.
Stage 1, landing leg deploy.
And there you saw the Falcon 9 first stage successfully land, and you can probably hear the cheering behind me. The Falcon 9 first stage that supported today's mission landed for the 7th time, having previously supported Amazonas Nexus, SES-22, iSpace's Hakuto R Mission 1, and 3 Starlink missions. Today's landing also marks the 178th successful landing for an orbital-class rocket. As mentioned previously, today's recovery operations are being managed by an all-female recovery team, and this is a really cool moment for the industry and SpaceX. There's that call out that stage 2 FTS is saved. And we should have second stage engine cutoff here shortly.
Seco.
There's that call out of Seco.
Nominal orbit insertion.
And there's the key call out of nominal orbital insertion. At T plus 9 minutes into the mission, we are coming up on the last major task for stage 2, commanding separation of Dragon a couple minutes from now. We expect to have video of Dragon separation from the top of the second stage, which looks into the trunk. CRS-27 will be joining the Crew 6 vehicle, currently on orbit, so we'll be back to having 2 Dragon spacecraft docked at the International Space Station.
Expected loss of signal. Okay.
As for cargo, today we will be delivering more than 6,000 pounds of science, research, crew supplies, and vehicle hardware to the orbital laboratory and its crew. To date, SpaceX has sent and brought back over 270,000 pounds of crew and cargo to and from the space station. As a reminder, this is the 3rd flight for this Dragon capsule, having previously supported CRS-22 in June of 2021 and CRS-24 in December of 2021. Once the Dragon capsule jettisons from the second stage, it has 16 Draco thrusters, each with the capability to deliver 90 pounds of force, and those will be used for maneuvering. There are 4 pairs of 3 thrusters spaced evenly around the capsule, as well as 4 forward bulkhead thrusters underneath the nose cone. Now, notably, Dragon does not have super Draco thrusters, seats, or life support systems, as it is not carrying crew, and this saves on weight, space, and also allows for a faster refurbishment time. And while initial designs of Dragon carried solar arrays extended outward from the trunk, the cylindrical structure located directly behind the Dragon capsule, the current Dragon has these arrays fixed directly to the trunk. And you may see at some point both a light and dark side of the trunk. And that dark side is actually those solar panels. And the light side is a radiator to help cool the spacecraft. And once the Dragon capsule reaches the ISS, it will be able to autonomously dock using its navigation sensors, centerline camera, and light detection and ranging equipment. It's also good to note the Dragon capsule is connected to the trunk beneath it via the trunk claw and connects thermal control, power, and avionics systems components between the trunk and the capsule. And if you're just joining us, you're watching a live view of Dragon successfully disconnecting from the second stage, heading to the International Space Station. This is the 27th commercial resupply mission to the International Space Station for NASA. This is SpaceX's 17th mission this year and 2nd Dragon flight to station for 2023. We lifted off about 12 minutes and 23 seconds ago from Kennedy Space Center at Historic Launch Complex 39A. And there you can see Dragon slowly drifting away from the second stage. The next milestone coming up is the nose cone opening sequence, which protects the docking ring and navigation sensors. And that's going to do it for me here in Hawthorne, so I'm going to throw it back over to Dan in Houston.
Hey, thank you so much, Zach, and hello everyone once again from Mission Control Houston. Great to see another Dragon on orbit. You've got a happy team here in Mission Control, and we'll have a happy crew of 7 astronauts and cosmonauts on board the space station when they wake up tomorrow with Dragon now on its way. As Zach said, the next milestone that we're going to be keeping an eye out for is going to be the nose cone open. This takes a couple of minutes, and that's to open the nose cone, so it's exactly what it sounds like. It's at the very top, or the nose part of Dragon, and that's going to slowly open up to reveal a couple of different components. That nose cone stays closed during the flight up to orbit, just to protect some of those more sensitive instruments from the thermal and aerodynamic loads that Dragon's experiencing on its ride uphill. Once it opens up, we're going to be revealing a couple of different things, including some propulsion elements, primarily 4 forward bulkhead Draco thrusters. Those are the primary thrusters that Dragon is going to be using for its major delta velocity burn. So those are just firings of the engines to gradually raise its orbit as it gets closer and closer to the space station. It's also going to reveal a suite of navigation equipment. Dragon has a couple of different methods to essentially find its way through outer space, and underneath the nose cone there is something called the Dragon Eye, star trackers, and then it will also be pairing that with an inertial measurement unit and GPS sensors, all of these kind of working in tandem to essentially tell Dragon where it is in outer space and where it needs to head. We also do what's called a state vector upload to the spacecraft just prior to launch, telling it where space station is, and then once it gets closer, we'll have what's called relative GPS systems that will be able to talk to each other between Dragon and space station, just as they start talking to each other, let them know where they are, and those come really in handy when we start getting into the integrated operations, which you're going to be seeing a lot more of this room once we arrive on Thursday morning, as when we're in integrated operations, you've got a team here in Houston and a team out in Hawthorne that are working to bring us Dragon in. But we are getting closer to that nose cone to start opening. There are 12 hooks around essentially the docking ring of the Dragon spacecraft. 6 of those are actually holding the nose cone in place during the launch. All 12 are closed when we're launching, and we open them up. If you've watched any of the previous crew missions or even the cargo missions, we do them in 2 different sets, 2 sets of 6. So one set already open, the second set opening now, and once that second set is open, the nose cone will start to deploy. Again, it takes a couple of minutes for that nose cone to open, usually about 5 minutes or so, and then it'll gradually open. It swings open a little more than about 110 degrees, so that gives Dragon plenty of clearance to dock with the space station, as this is going to reveal also the docking ring, and that's what Dragon's going to be using to actually dock with the International Docking Adapter on board the station. Again, we're heading to the forward port. We have 2 of those on the U.S. segment right now with the docking adapters, the forward port and the Zenith, or the space-facing port on Node 2, the Harmony module. And this Dragon is going to be bound for the forward port. It was just left vacant by the Crew Dragon Endurance, which brought Crew 5 home over the weekend after 157 days in space. And this Dragon is bound for that one to kick off really about a month and change of really intense cargo and science operations. But at this moment in time, one set of hooks open. We're still waiting for that second set of 6 to open up. And then once that happens, the nose cone will start to deploy. Shortly after that, we'll do checkouts of those forward bulkhead Dracos, those 4 Dracos that are hiding underneath the nose cone right now. And once those are checked out, we'll be pretty much ready to go. And as Dragon will start to do its different phasing burns to get to the space station. And sounds like we've got all 6 of the second set are now open and just standing by, and it looks like the nose cone has started to deploy. So again, this is going to kick off a couple of minutes for the nose cone to fully open, but all hooks are open and the nose cone is deploying. While we wait for the nose cone to open, I do want to bring in, we have a guest real quickly. We have Phil Dempsey. He's the manager of the Vehicle Integration Office in NASA's International Space Station program, basically the guy overseeing all the different spacecraft responsible for bringing crew and cargo up to the space station. Phil, first, thanks so much for joining me. Just want to get your thoughts real quick. Walk us through, we've got another Dragon mission heading to the station. What's this going to mean for those crew members on board?
Hey, yeah, thanks. So first of all, just saw a really great launch from our SpaceX team down here in Florida. Getting a new Dragon is really exciting for the group for a couple of reasons. First, like you just kind of mentioned, these cargo missions are really action-packed times for the crew. It starts when they dock Thursday morning. We're just getting into the vehicle, getting critical research out and into its location on the ISS. Then the crew does some standard cargo ops and payload moves across this 30-day mission. But while they're doing that, they're also doing critical research that actually has to be completed during the dock mission in order to get those results back down on that same vehicle when it comes down a little over 30 days after it goes up. Then it's time to get it repacked with hardware. Additionally, these cargo missions are the few chances we have to get fresh or refrigerated food up to the crew. So, we give them a little taste of home. They've got some fresh fruit and cheeses on this one.
And I know they're asleep, but I think they're going to be pretty excited when they wake up. We actually have some live views now of the nose cone opening. We're about halfway through. But Phil, before I let you go, just general feelings from you, the program. This has been just another incredibly busy spring. It feels like we're always in the busy season with Station. We just brought a crew home over the weekend after launching another one. What's it been like to just balance all of the traffic coming and going from the space station?
Yeah, it seems like we're partway through and there's a lot going on. It is really exciting. As for the pace, most of us probably wouldn't have it any other way, I'll tell you. We're in our third decade of operating this orbiting research facility, and these are the crew and cargo missions to keep it going. But if you look ahead, added into that mix, we got an upcoming Boeing first crewed flight. We've got a second private astronaut mission. So while busy times for sure, it's really inspiring what we're doing across, in this industry, across this, dedicated and great partnerships with NASA, commercial, providers and international teams. It's just really exciting for the program, and we're really proud to be part of it.
All right. Well, again, that was Phil Dempsey. Phil, thank you so much for dialing in. And Phil's the manager of the Vehicle Integration Office from the International Space Station Program for NASA. Thank you, Phil.
All right. Thanks. You have a good evening.
You too. All right. We are very close now to the nose cone being open. Looks like it just has a few more degrees to go. And we'll stand by and wait for confirmation on the loops to hear that again. Once we get the nose cone open, it'll be time for Dragon to reorient itself to maneuver for some forward bulkhead Draco checkouts, and then that'll be the last thing we do in the next couple of minutes before it's time to start those phasing burns. And as I was talking through there, we actually just heard the nose cone is now open. So Dragon already stepping through its automated sequence, getting ready to do the checkouts of those forward bulkhead thrusters. And then once those are ready, we'll be set up and good to go and ready to do our phasing burns. So really great to have a Dragon back on orbit. The 27th resupply mission to the International Space Station on its way. A safe, healthy Dragon, bringing over 6,000 pounds of cargo.